One way you can find factorizations of a number is to use a factor tree. The animation shows how to use a factor tree to help you think about the factorization of the number 300. First, record any two factors of the number. Here, you will see 300 is equal to 10 times 30. So they create branches for 10 times 30. So then you have to notice that 10 and 30 are composite numbers. So that means we can use more factors to break each number into more branches. 10 has 2 times 5. 30 has 5 times 6. Did you use these factors or different factors? You are going to repeat the process with any composite number. In this example, the only composite number left in the tree is 6. So they're going to break 6 down into 2 times 3. Can you see the different factorizations represented in the tree? There are more ways to factorize 300 than 10 times 30. So let's do this one together. I'm going to use 5 times 60. So then I have to realize that 60 is not prime, so I need to break it down even further. I'm going to break it down into 2 and 30. So 2 is now prime, but 30 is not prime. It is still composite. So I'm going to break it down even further. So 5 is composite, but 5 is prime, but 6 is not. So then I want you to circle all the prime numbers that you got. I got 5, 2, 5, 2, and 3. So I can turn this into an expanded form of exponential notation. So I'm going to go least to greatest, so smallest to biggest. So I see 2 2s, and then I see a 3, and then I see 2 5s. So I can condense this into an exponent. So I have 2 to the power of 2 times 3 times 5 to the power of 2. Let's try one more. Let's look at 72. Well, I know my facts, and I know that 8 times 9 makes 72. Now notice that 8 and 9 are both composite, so I'm going to have to break down each number into its own branches. So let's start with 8. I know that 2 times 4 make 8. 2 is prime, so I can't divide it anymore because it's just 1 times 2 is how you make 2. But I can break apart 4 into 2 times 2. So now all of my tree for 8 is done because I'm down to all prime numbers. So let's move on to 9. I know that 3 times 3 makes 9. So I can't divide that anymore because 3 is prime. 1 times 3 are the only numbers that make 3. So I'm going to circle all my prime numbers at the end of my tree. And then I'm going to make my sentence. I see 2 3 times. So 2 times 2 times 2. And then I'm going to do my 3's. Times 3 times 3. So then I'm going to condense it using exponents. I have 2 to the power of 3 times 3 to the power of 2.